as we said earlier, since we aren't normalizing the covariance value, it doesn't really convey useful information about the strength of the relationship. I should say that over here. That seems to have been messed up. The strength of the relationship between two variables. And when we're talking about two jointly distributed random variables, x and y, we can define the covariance in terms of the expected value of x and the expected value of the overall difference between x and the means, as shown over here. So let's take a little bit of an example. Let's do this on a different slide before we come here. So we want to say calculate the covariance for the following data set. We have x is 2.1. Let me write this down on a new slide. Let's go back. 2.1, 2.5, 3.6, and 4. And y, in this case, is 8, 10, 12, 14. And then the mean over here is, we can calculate from these values, it turns out 3.1. And the mean over here is 11. So how we're basically going to go about calculating the covariance in this case is we're basically going to subtract each of these quantities from the mean, multiply them together, right? So remember what we said. We said sigma xi minus mu x, yi minus mu y for all I divided by n minus 1. So what that's going to give us in this case is we're going to have 2.1 minus 3.1 multiplied by 8 minus 11 plus, that's 11, sorry, 2.5 minus 3.1 into 10 minus 11 plus, just making sure, yep, because doing live math is always 3.6 minus 3.1 into 12 minus 11 plus 4 minus 3.1 into 14 minus 11. We can calculate these. So this is, sorry, I think I need to make this a little bit clearer. To remove that. Let's just say this is 8 minus 11, not plus. So that would be minus 1 into minus 3 plus minus 0.6 into minus 1 plus 0.5 into 1 plus 0.9 into 3. Of course, this whole quantity divided by n minus 1, which in this case is 3. So all of this divided by 3 again, which is equal to 3 plus 0.6 plus 0.5 plus 2.7 divided by 3, which is equal to 5.7 plus 0.6 is 6.3. Plus 0.5 is 6.8 divided by 3, which is equal to 2.2, I want to say 2.267. So, okay, yeah, turns out we were right. Okay, so this is one example of how to calculate variance. Let's take maybe similar values, but let's try and calculate in a different case, right? So we have, let's take the same values over here, 2.1, 2.5, 3.6, and, oops, sorry, 4.0. And the mean is 3.1. And for y, now let's take 5, 3, 2, and 1. So what is the mean in this case? The mean would be 5 plus 3, 8, plus 2, 10, plus 1, 11 divided by 4, which would be 2.75. I'll change my color. All right, so how do we calculate the covariance in this case? So, sorry. So we have, again, let's write our formulas, xi minus mu x multiplied by yi minus mu y, the whole thing divided by n minus 1. So what does that look like right now? So that looks like 2.1 minus 3.1 into 5 minus, this is a slightly hard number to deal with. So yeah, okay, let's just keep it as it is. 5 minus 2.75 plus 2.5 minus 3.1 into 3 minus 2.75 plus 3.6 minus 3.1 into 2 minus 2.75 plus 4 minus 3.1 into 1 minus 2.75. And this entire thing divided by 3. I am just going to use a calculator for this. So let me just pause this recording. Feel free to pause it as well, but I am going to calculate this and then I'll put the answer. Okay, so the answer that we got was negative 0.7625. And what that means in this case is that the quantities x and y are negatively, they vary negatively with each other, which means as x increases, y decreases, which is kind of what we see over here. So that's another example of how to calculate covariance, and that hopefully these two examples, they're fairly easy, but between the two of them give you a sense of what covariance is and how we can calculate it for data sets that are of the nature that we've seen over here. So finally, we just want to talk a little bit about the applications of covariance. Covariance is a useful quantity when we're talking about feature selection and algorithms. When we talk about machine learning, there's the idea of principal component analysis, which basically helps us reduce the number of features that we have in our model that'll help prevent overfitting and basically make sure that our model doesn't have too much variance in it. Covariance is a concept that's used in finance when we're talking about different asset classes, when we're talking about different types of assets, different, for example, even different stocks, when we want to see how two assets vary together. You're interested in making sure that your portfolio is balanced and diverse enough that you don't have too much risk concentrated in assets that will move up or down together. So that's another area where we use covariance. And finally, it's also used in molecular biology, it's used in genetics in order to study secondary, tertiary proteins or RNA structures. This is not something that we have too many examples about, unfortunately, in this lecture, but it does seem very fascinating. All right, see you in the next video, and thank you.